Hey everybody, it's Ben here, and I'm headed over to pick up a used treadmill right now that I found for 10 bucks. Why and what does this have to do with electric vehicles? You will just have to find out next. I was able to buy this used treadmill, lug it into the back of our Chevy Volt, and safely transport it home. Then I pulled it out, took a look at it, plugged it in, make sure that it was indeed working properly. Of course, my daughter and her friend had to test it out right away. After that, I decided to take a look if it would work with my car. So here's my Mitsubishi i-MiEV compared to this treadmill, and it looks like one wheel would be able to go on the treadmill just fine. It's got the ground clearance over here for the body, but the issue, even up here, I can unbolt that. Just got to take a couple bolts out. I could get this out of the way, but kind of this big front end is going to be a little too tall for the underbody because this is a rear-wheel drive car. If this was a front-wheel drive car, I think I could just pop it up there. Now, my understanding is that most motors for treadmills are actually DC. So in theory, I should be able to swap the polarity and make this spin the other direction. Because if it did, it would be very, very easy to get the car onto the treadmill and not have this part here in the way. Oh, that was easy. So let's take a look inside here. First of all, we've got our AC power cord that just comes in through a main power on off switch. And then inside we got some components. We've got this board here, and a couple of things I noticed right away is we've got 4 diodes together. That's a pretty good clue that the AC power is being rectified to DC right away. And then another thing is over here, we've got what looks like a transformer at first, but it only has 2 wires going to it. So that's actually an inductor. Right behind it, we've got a big old capacitor. It does have a nice rubber cover on it here. And a couple other components on this main board, like right here is a heat sink that on the back of that, that's going to have a MOSFET. So basically, power comes in, it gets rectified to DC, and then DC is controlled with pulse width modulation to vary the speed. So if we come over here and take a look at the actual motor, we can see on the end of it, we've got a flywheel. If I just turn that flywheel by hand, the belt moves, but it's got some pretty good gear reduction to it. On this end, we can see we've got a small pulley on the motor, a bigger pulley on the treadmill belt. We also have fan blades for a little bit of air cooling on this motor. Let's take a look at the tag. This is an 88 volt DC motor rated for 15 amps, 1.5 horsepower continuous, 2 horsepower intermittent, PM, so it's a permanent magnet motor. And this style of motor is very common, very easy to control the speed of. And the other thing that's interesting is down here on the end, there's kind of this cogged, toothy thing. Let's find a good angle for that. On the flywheel end of the motor, you can see there's kind of a sprocket-like shape. And right up in here, we have some sort of a sensor. And so if we move, I'll just move this by hand, you can see that those sprocket-like teeth either block or not, that little gap in there. So I believe that's an optical sensor. It could be magnetic, but probably optical. And so that is going to be some feedback information so that as the motor spins, there's a speed info going to the controller that makes all this work. We know this is a DC motor, and right down here we have a black wire going to a power connector down there. And up here, a red one. Pretty obvious, that's positive and negative on the DC side of things. We also have a green wire, which seems a little weird, but that's just a chassis ground. So that's going to be just connecting everything grounded together, all the conductive, metal parts of the machine here. So as the motor spins, we'll see the flywheel on the end rotate. Other end has a fan, pulley, belt, and then that moves this right here. But what if I wanted it to spin the other direction? Because that's one thing that's actually pretty easy with permanent magnet DC motors. If I simply pull off the wires here, and I'm going to swap the positive and the negative wires. One last thing on here is we do have a device right back here. Basically, we've got a reversible motor to some gearing and a screw, and this makes the front of the entire unit go up or down, so that's our elevation control on the treadmill. So with the polarity to the motor reversed, I'll turn the machine main power on. And then on the controls, I'll just start it up to a basic program and turn it on. And you can see that the belt is going reverse of what you'd expect. It's going forwards. Now let's try something a little different. Instead of using the motor to power the treadmill, I'm going to pull off the connections that would power it. And let's instead hook up the voltmeter. Get these wires out of the way. Just going to connect these where the motor power connections were. And now let's connect our test probes to those. Make sure they're out of the way, they're not touching anything else. And now let's walk on the treadmill, see what happens. Oh, it's hard to get going, I'll tell you that much. I really gotta lean into the bar here. Ooh, gotta really push on there. We're at like 6-7 volts. And on a DC motor, voltage and speed are proportional to each other. So if I can walk faster, that voltage is gonna go up. Let's see if we can get it around 12 or 13. Because that's basically like what a car with a car battery and alternator is going to be running around at those voltages, 12 to 14 volts. And this is a decent walking pace. A little tiring, but I can do it. And we're just measuring the voltage, but what if we hook something up to it instead? So now I have here a traditional incandescent light bulb, but it's not a 120 volt, it is a 12 volt 50 watt light bulb. These are kind of designed like for a trouble light for a car where you just use jumper cables straight onto your 12 volt battery, for example. But basically it's a light bulb, but I should be able to run it at a little over 12 volts with the treadmill. So I've got a base I can screw it into, and then I'm going to connect the wires out to the motor, which we're using as a generator. Okay, here we go. I got the light bulb down here. I've got the voltmeter and the 12 volt light bulb both connected up to the treadmill. Let's see what happens. Oh, that's harder to, that's a lot harder to walk. Oh God. Oh, boy, I really gotta, oh, I really gotta push on here. That is work. And let's see, 9 volts. Oh God. 10, 11, 12, almost 12. Here we go, 13, 14. Woo! And that's really tiring. Woo, that was harder than I thought it was gonna be. I think an exercise bike generator is easier. Woo! So, can you use a treadmill as a generator? Absolutely you can. I don't recommend it unless you're really fit and got nothing better to do. I have now chalked 3 of the wheels. I've got some wood blocks underneath them, And the wheel closest to us here, it's off the ground. It doesn't really look like it at this angle, but it's clear of the road by about 1 inch, and I've lifted it with a jack, and I'm holding it with a jack stand. So I'm going to turn traction control off and put the car in gear, and what should happen is, because of the differential, that wheel will stay still, and this one will spin, and I'll be in the car with my foot ready to go on the brake. Here we go from park to drive. And taking my foot off the brake. And it gave me an error on the dashboard. Here we go again, traction control off. Okay, we're in gear. Okay, no errors. Went up to about 9 miles an hour. Next, it was time to get the treadmill under the car. Of course, I'd need to jack this up. I needed about 7 inches or so of clearance. I needed to jack this up, support it with the jack stand, make sure everything was safe and secure, and then test the wheel spinning while it was in the air. Before we try regenerative braking on the treadmill, let's test out the generator feature again, as I'm sure the car can run the treadmill a lot better than my legs could. So I'm trying to put a little bit of weight on here, just enough to do the friction, but not so much to brake the treadmill. It's in gear. Slippage. Too fast. Gonna try to put just a little more tension on the belt. Looks like about 18 volts. Okay, so here we go. Here's our camera view, and in the car, our traction control is turned off. And we can see that on the dashboard. Traction is off. Now I'm going to put it in gear. I'm actually going to use the eco mode and take off. I've got a hand parking brake, so we'll turn that off. Eco, and ease my foot. Close the door to stop the darn beeping. And ease my foot. Here we go. Gently off the brake. It's funny, the dashboard says we're going 2 miles an hour. Before, when the wheel was just up in the air spinning, it was hitting like 9 miles an hour. So this is a terribly inefficient way of getting electricity out of an electric car, but it does in fact work, even though it's just terribly inefficient and janky looking. But what I really want to know is if I could charge the car like this, if I instead send power in to the treadmill over an extension cord to a wall outlet, could I spin the treadmill and get regenerative braking to work on the car and actually charge the car. So the first thing I got to do is get back down in here, remove all the connections for our little generator setup, get these out of here, hook it back up, making sure to connect it in reverse polarity so that we're running the treadmill the right direction for the car. And just remembering from what I did earlier, from this camera angle, the red connector has to go to the near side and the black has to go to the far side for that reverse polarity to run the treadmill backwards. Now, your typical treadmills also have kind of this dead man switch. You hook this to your belt, and if you fall off the treadmill or something, it pulls this out and the treadmill automatically shuts down. So I think I'll run a longer piece of line on this so I can run it up to the front of the car, just in case. Here we go. I just rigged up my emergency stop cable going up into the car here. Just a little piece of tape, just tacky enough to keep this from slipping out under the weight of the cable. So I think what I'm actually going to do is I've just put the car in neutral. Now I'm going to plug in the exercise equipment, plugging it in, and turn on the power. This is with the car in neutral. The wheel is being spun by the treadmill. I will say this is vaguely hypnotic. Treadmill is powering the car at 1.5 miles per hour. Let's take it up a notch. The car is only going 1 mile per hour right now, and I do not think that is enough for regen, but I'm going to shift the car into our eco mode, which has gentle acceleration but a little more firm regeneration. See if anything happens. Actually sped up as I put it into gear. And the car is actually fine. It's the treadmill that just had an error, said we're over speeding. And if I try to change the speed, nope. Looks like I gotta restart this thing. Okay, car is back in neutral. I rebooted the treadmill. I just turned the power off and back on. It's set to go again. Car's in neutral. I'm going to try to make the treadmill go a little faster now. One and a half miles an hour. 3 miles an hour with nobody in the car at the brake. Now I'm going to see if I can just pop it into gear so that instead of spinning it too fast, we go straight to regen. We'll see. Here we go, straight to eco. Okay, we did not get an error on the treadmill. Let's try taking it up speed a little. 4 miles an hour. And I don't think I'm going to go any faster than this without some assistance. I got my young assistant to help me so that she could operate the treadmill while I operated the car. Okay, kind of click up to like 3 miles an hour. Okay, so go up faster, get to 3 miles an hour. Hang on, just let it go. We got the treadmill going a few miles an hour and then put it into a drive mode that supports regen. Okay, now turn it up to 4 miles an hour. Go to 5 miles an hour. Take it to 6.
It's at 6.
Take it to 7.
It's at 7.
Okay. It says 4 miles per hour on my dashboard here. We worked up from low speed all the way to the maximum speed on the treadmill, and while I was doing this I also had an OBD2 device that connected to just an old Verizon Android phone so I could monitor voltage on there. Unfortunately I ran into issues while we were using it. I think Okay, I lost connection on my little info thing here.
Oh no.
Okay, take it up. Go up to like 7, 8, 9 miles an hour. We took the treadmill all the way up to 10 miles an hour, but still were not regenerating electricity in the car. I even tried going to a different gear shifting on the fly, but all that did was set off an error light in the car and also an error on the treadmill. Oh, we broke the belt! Oh, oh, folded it! We folded the belt! Whoa, weird!
Yeah. I was kind of noticing that it was like not over here anymore.
Here we go. This is interesting. So we did end up with a problem on here. I think just switching gears while it was still on. But more interesting, I thought we tore the belt, but it's like folded over.
It's weird.
It's like, it's a seam. It's like what do you call it? Where like you fold it over it and iron it and everything. And I'm sure that's just because, you know, the tire here is on an angle. And if you look, where that fold is exactly kind of the peak of where the tire was rubbing against the belt. Well, this was certainly a fun little adventure, but the car did not regenerative brake rolling on the treadmill. You know, I tried getting it up to speed, just being in neutral up to about 3 or 4 miles an hour, popping it into the regenerative mode, and still didn't happen. Maybe it's just because with the differential, we're kind of getting only half the speed out of the system just by powering the one wheel. Maybe there's a sensor that prevented it. Going out worked great. We were very easily able to light up that light bulb, but for regenerating, no luck. So as far as like a Mythbusters kind of a thing goes, if you want to power a car by charging it regeneratively with a treadmill, it's probably not going to work. You can see here how the belt slid over a good inch and a half, and the extra material is just folded right up here. Here's just a little more of the aftermath I noticed. If we look down here, see if we can, there we go, at this angle you can see it. That is rubber dust, basically. Any of those times that the tire was slipping on the belt, it was wearing the belt down, and or the tire, I don't know which, really. They're both just black rubber, and bits of it was flying up here. And you can see a little bit more over here. Probably not as well as right here, though. So that is definitely a sign of inefficiency. You know, you do something electronically, at least you're not physically wearing things out like you do trying to use a treadmill as a generator. So, what did you think of this experiment? Should I do it again? Doing something a little bit differently next time? It was kind of hard to do too many things at once, especially paying attention to safety, but maybe I need another person to do some monitoring. A couple of things I can think of are that the angle of the car was really wrong to give maximum power from the wheel to the belt, just because it was on an angle here, and that's also what led to creasing the belt. So possibly I could raise the other wheel. I think I just didn't get enough speed to do regeneration. So maybe I could soup up the treadmill to get to high enough speed that I could power it with one wheel, or maybe I could get a second treadmill and run them both. Who knows? But I'd definitely like to hear what you think. Until next time, stay charged up, but probably not with a treadmill. Come say hello at 300mpg.org. Tell your friends, share this, click, like, subscribe, do all those things YouTubers are always telling you to do, and we'll see you next time.